Today I'm going to show you how to use the analog output of the low-level signals in real time. We have wired these MC950s to output signals that's coming from these channels. These are low-level signals which they are in millivolt per volt range. So the outputs are very low, so has to be conditioned. So there are conditions inside the box, and then they route it back into these connectors. Let me see. In here, I'm showing you the pinouts for this connection. These connections are ground, channel 1, 2, 3, 4, as it shows on these wires. It's just a small connector for prototyping to show you how we can access these signals. But in actuality, you need a good cable which connects this signals from this connector to your high-level input data acquisition system. Here you see the pinouts. We want to mostly look at the signals in this area. And these are the analog outputs from channel 1 all the way to channel 8. This particular units that we have wired are 4 channels, so only these signals are you'll be able to see the signals from here. There are other analog output channels which are in this section. These relates to ultrasonic outputs as analog signals. We are not talking about these signals for this video. We are only concerned about the channel 1 through to channel 4 signals. Again, is a shot from above. It shows you exactly where these pins are, and also the drawing gave you a good idea on this. So what we're going to do now, we're going to just make it work and show you how this thing works. Right now I've connected a torque transducer to channel 1, and also I have a voltmeter which is measuring the voltage on channel 1 between the ground and red wire, which is channel 1. So let me fire up the MC911. That's where we are in the MC911. We go inside the acquired setup and channel 1 as I showed you, and we can read the sensor, which is from torque transducer, transfer it back here. Here we have a torque transducer 170 Newton meter of full scale and calibration value of 168.37. So we go into calibration. In calibrate, we just as normally we start we calibrate it. Okay. At this point, it's just normally showing you what's output. If you want to engage to show you the output level of the MC950 when at 168.37, we engage this. So if I go back, this is what I'll be reading, 3.244. That's with that engaged, with the calibration resistor engaged fully, so it will show you 3.24. These signals are normally between 0, 3 to 4 volts. And this should be sufficient for any of data acquisition units which can handle high-level signals. So it's a plus-minus value, so it can go either direction. And if I take it off, then the signal will go off. To measure the zero voltage, you have to exit this. At this stage, if you come back and measure it, let me go to the next screen. This is fully engaged, and this is when it is not engaged, when you're out of that window. So this is your 0 volt value. And that shows you 0 volts, so you can adjust your acquisition signal that's entering into your acquisition system, that what voltage values mean. So again, going back here, when it's fully engaged, you actually outputting 168.37 volts. When you are disengaged, around close to 0. So this concludes the video on analog output for low-level signals.